Hello everybody and welcome to another video from Carl's Tech Shed. Well, what I've got for you today is this. This is a Coldplay Xyloband. I've picked this up on eBay for about £3 a few days ago, simply because it doesn't work. What these were used for, when you went to a Coldplay concert, they'd give everybody one of these wristbands, and in certain parts of the concert a wireless signal would be sent out and all of the wristbands would flash and light up. So it looked like a very fantastic effect. You can see some of the videos on YouTube and they look quite good. But what I was interested in, I wanted to see how they work, because a couple of websites mentioned that Coldplay almost went bankrupt by giving these out. So I thought there must be something quite unusual inside, or possibly quite expensive, which means that they almost went bankrupt giving these out. So I thought we'd do a teardown of it and see what's inside it. Well, now that I've taken the plastic housing off, as you can see we've got a very small PCB here. We've got two wires going off to these LEDs along here, and we've got another pair of wires going off to the LEDs in this half of the band. Now on the top here we've got a small battery compartment. If I pop that out, now this actually contains two batteries. These are CR2016's 3-volt battery cells. If we flip it over, we've got another battery here, which is again a 3-volt cell, but this is a slightly different model because the battery seems to be slightly thicker. This is a CR2032, which are very common in, or were very common up until recently in PC motherboards and such. Now if we have a look at the board we've got here, we've actually got two very small ICs on here. We've got one just here and one just under this piece of metal. So what I'm going to do is, obviously because this band doesn't work, I'm just going to cut these pieces of metal off so we can actually have a closer look at them. Well, now that I've taken the battery clips off, you can actually see what processor we've got under here. We've got a very small 8-bit microcontroller which is made by Silicon Labs. This has 8 kilobytes of ROM and 512 bytes of RAM. We've also got a built-in analog to digital converter in there. Now just next to that we've got silicon, also made by Silicon Labs, an SI4313, which is an RF receiver. So this will be picking up the wireless signal from the concert. This will then be processed and then sent into the microcontroller. The microcontroller then processes this signal and causes the LEDs to flash in the wristband. Now what's interesting about this side is that we've got some configuration pins here. We've got some, I'll read them out for those of you that can't see them. We've got GND, which is obviously ground. We've got C2K, C2D and VDD. Again, these will be for initially configuring the microcontroller. And sorry, just under here I noticed we've got TX and RX, which is transmit and receive. But these seem to be going into the RF receiver, so most likely this would be for configuring the frequency for the RF receiver, because obviously every country would have a different frequency depending on their regulations. Now if we flip the board over, we've actually got a very crude form of battery pickup connector here, because this was originally where the 3-volt battery was on the back. So this is just a series of solder blobs on the PCB. We've got some more configuration connectors here, so again these would be for configuring the microcontroller initially. We've got a handwritten serial number here which is 0483, and if we turn the board this way we can actually see in very small letters there that we've got, it says that this is version 03, so obviously there were two versions before this. I know this to be a fact because I've actually had a look on Google and I've actually found a picture of an earlier model of this board, and instead of having a Silicon Labs controller it's actually got an AT-MEGA48 controller, which would be quite a lot more expensive than this microcontroller, and effectively they would be doing exactly the same thing. So it's quite an interesting board, really. Quite a very neat design, and the fact that it can also be put into standby mode over the RF frequency to preserve battery life also leads to the fact that they could be reused at different concerts if you replace the battery in them. So yeah, overall it's a very interesting little board. Build quality isn't too bad, to be honest. I think the only thing I picked up on was the contact side of this battery, where you've got some solder blobs instead of an actual connector, but apart from that it's quite a well designed board. I have no idea how much this would cost to actually manufacture, but the microcontroller itself is about 54p when you buy them in quantities of 1,000 or more, and the RF controller is about 35p when you buy them in quantities of 1,000. So I mean, including manufacturing costs, the actual cost price of each board is probably, you know, the whole band, you're probably looking at about £4 or £5, something like that. If it's any more than that to produce, then I can only imagine that they're whacking on some R&D costs. Not that there's much really to research and develop on this. I mean, it's a very simple design, really. It's quite a good little board, really. It's just a shame that you can't really reuse them unless you've got a 869.5 megahertz transmitter. Well, thanks for watching the video. Leave your comments in the comment box, and please subscribe. I'll have some more videos up soon.